Okay, today we're going to look at solving rational equations. So we're going to have the same sort of thing we did for adding and subtracting. The only thing that's going to be different is it's an equation, which means we're going to have to solve it for x. So instead of just having a general sort of answer, our answers will be things like x equals 2, or x equals 5, or x equals negative 1/2, or something like that. So let's go through a few reminders on how to do fractions with equations to kind of remember the rules, and then we'll be able to solve some of the harder ones. So this first one, just a simple fraction, x over 5 equals 6 over 10. Just using some cross multiplying or some easy conversions, we know the answer is going to be x equals 3. So let's kind of figure out how we do this in terms of rational equations. So just like for adding and subtracting, what we want to do is make sure we have common denominators. So in this case we have 5 and 10. So what we want to do is change them both so they have a common denominator of 10. So you can see the left or the right fraction, 6 over 10, will stay the same. And what we'll have to do is change the first fraction to get a 10 on the bottom. We would times top and bottom by 2. Right? Whatever we do the bottom of fraction, we have to do the top. So then we should get, for our new equation, we should have 2x over 10 equals 6 over 10. And with equations, once you have common denominators, if the bottom of the fractions are the same, that means the top of the fractions have to be the same as well. So if we do that, if we just sort of ignore the bottoms, then our equation simplifies down to 2x equals 6, and we're pretty much done. We can just solve it for x by dividing by 2. So then our final answer is x equals 3, like we said. Okay. The only thing you want to do is with the equations is plug that answer back into the original equation just to make sure it works and to verify that that value is not a non-permissible value. So in this case we put 3 back in, we get 3 over 5. Is that equal to 6 over 10? Yes, it is. Our answer is good. There is no non-permissibles for this one, so we have nothing to worry about. So let's try another one that's a little bit different. So if I gave you 2x over 3 equal to 6 over 5. So it's a similar kind of question, pretty basic question. So we'd have our common denominator in this case would be 15. So we'd want to multiply our first fraction by 5 to get 15. So that would give us 10x on the top, and we multiply the second one by 3 to get 15 on the bottom. So that gives us 18. And once again, if our denominators are the same, we can ignore them and just solve the top. So we'd have 10x equals 18, divide by 10. So we get x equals 18 over 10. We could write it as a fraction or a decimal, 1.8, however you want is totally fine. And if we plug that back into the original question, again, it will work out just fine. So with these kind of questions, they're fairly basic. Just make sure you have the common denominators, change the fraction just like you would for adding and subtracting. Then the only thing that's different is we then solve the equation on the top part of the fractions. So let's try one more that's a little bit harder. So we have x over 8 plus 3x over 12, and that's going to be equal to 6. Okay. So in this case, we have a common denominator. We have 8 and 12, so our common denominator will be 24. So that means we want to change everything to be over 24, including the 6. Because remember, in the question, if there is nothing on the bottom, we could always think of that as being over 1. So to get everything to be in 24, we're going to times our first fraction by 3. So we'll have 3x. Our second fraction, we need to times it by 2. So that would give us 6x. And then for the last one, we'd have to times it by 24. So 6 times 24 is 144. Okay, so now that we have the common denominators, once again we ignore the bottoms. So our new equation will be 3x plus 6x equals 144. So if we simplify that, we get 9x equals 144. So 144 divided by 9 gives us an answer of 16. Okay, and once again, if we plug that back into the original question, it does work out. 16 divided by 8 plus 3 times 16 divided by 12 does indeed give you 6. So all of these ones, the answers are totally fine. Okay, let's try one with a little bit harder denominators. Okay, so we'll look at one where we have algebra on the bottom. So 1 over x plus 2 equals 4 over x minus 1. So in this case, our common denominators, we have two different polynomials on the bottom. So our common denominator is actually going to be both of them. We have x plus 2 for the first one and x minus 1 for the second one. So we need to do that for both fractions. Okay, so now when we do our tops, so on our top we have an x plus 2, so we needed x minus 1 for both to make the denominators the same. So our top would be 1 times x and 1 times minus 1. And then for our second fraction, we got the x plus 1, so we need our x minus 1, so we need an x plus 2 for both, top and bottom. So when we multiply the top, we'd have 4x plus 8. Okay, and just like we did before, our denominators, we don't need to worry about them. So we get x minus 1 equals 4x plus 8. So now to solve that, we want to, let's bring the 4x to the other side. So we'll subtract 4x. So that gives us minus 3x minus 1 equals 8. And let's add 1 to both sides. So that gives us minus 3x equals 9. And our last step would be divide by negative 3. So we get x equals negative 3 for our answer. Okay, so this is the kind of question especially where you want to check your answer. So if we go back to the original, in our original question, our non-permissible values, we couldn't have a negative 2, and we couldn't have a positive 1. So as long as our answer isn't one of those two, we're good. So in this case, minus 3 is different than those, so we're good. That is our correct answer. Okay, before we do another question, I just want to show you there's a couple different ways to actually solve these. So this first way is kind of like adding and subtracting, just make your common denominators the same and then solve it from there. The other option is, in this case, because we had just one fraction equal to another, so there was no extra adding or subtracting. So if you just get an easy one where you have two fractions equal to each other, kind of like this, you can cross multiply these, just like you did in junior high with normal kind of questions. You could cross multiply these as well. So you'd have 4 times x plus 2 equal to 1 times x minus 1. And you can see when we multiply those out, 4x plus 8 equals x minus 1. We get the exact same equation that we just solved. Okay. The other option, so that's one way, is cross multiplying. I would say don't cross multiply unless it's an easy question like this, because if you try doing a harder one, it's not going to work, but it does work for these easy ones. And another option is what some people do, and this is how the notes, the online notes explain it, is we can solve these by, instead of changing them to be common denominators, we just multiply the top by the common denominator. So it's a little bit different. So multiply top by our lowest common denominator. So we already knew in the first question our common denominator was both the x plus 2 and the x minus 1. So if we do that, if we multiply the top x plus 2 and x minus 1, we do that on both sides, x plus 2 and x minus 1, then what we do is we can cancel the fractions. So we have an x plus 2 that goes away on that one, and we have an x minus 1 that goes away on this one. So we end up with 1 times x minus 1 on that side and 4 times x plus 2 on that side. So you can see we get back to the exact same equation again. So 3 different ways of doing it, but they all work pretty much the same way. I recommend sticking with the first one because it ends up being just like we did for adding and subtracting. Make a common denominator, change all your fractions, and then all we do is we worry about the numerators. Once the denominators are the same, that means the numerators have to be equal as well. So that's my advice of how to solve these, and that's the way I'll stick with for the next couple examples. So let's try one more that's a little bit harder. So this one we got 2x over x minus 1 plus x minus 5 over x squared minus 1 equal to 1. So in this case, we can see we got more complicated denominator. And that's usually the only thing that changes with these is you get denominators that are a little bit more difficult. So just like we did for adding and subtracting, step 1 is you want to factor everything if possible. So in this case, we can factor the bottom of the second fraction. So the first fraction is good. Second fraction, we'd have x minus 5 on top, and we get, if we factor the bottom, we'd have x plus 1 and x minus 1, right? That's one of our square root type of factoring questions. So now when you look at this, we're ready to do our lowest common denominator for step 2. So we can see we have an x minus 1, an x plus 1, so we need both of them as our lowest common denominator. And remember, we have to do that on the other side as well, where the 1 is. Okay, so there's our common denominator. Now we're ready to multiply the tops to make them the same. So we have the x minus 1 on the first one, so all we need is the x plus 1 for top and bottom on that one. So our top would be 2x times x plus 1. Okay, for the second fraction, we got them both already, so we don't need to do anything. So our top would be the same. And then for our last one, we need both the x plus 1 and the x minus 1. Okay, so now we've changed all of our fractions, all of our denominators are the same, so we can ignore our denominators and just solve the numerators. So when we multiply the first one, we get 2x squared, and 2x times 1 would be 2x. Remember to FOIL these out. And then we have our x minus 5 for our second fraction, and on the other side, when we FOIL it out, we get x squared plus x minus x. Right? Remember, you got to do the inside ones. X minus 1, 1 times x, and then 1 times minus 1 would give us minus 1. And now we're ready to simplify. This one's a little bit more difficult because there's an x squared involved, so we get a quadratic. So instead of solving it for x, remember what we want to do with these is we want to get it equal to 0. So let's get the x squared over first. So that would give us 1x squared. Let's combine the 2x and the 1x. So we have 3x on this side, minus 5. And on the other side, the x's cancel, so we just get a minus 1. So our last step then is, let's just get rid of that minus 1 to make it equal to 0. So we'll add 1 to both sides. So we have x squared plus 3x minus 4 equal to 0. So now, because it's a quadratic, we get 2 answers. Typically we're going to get 2 answers, and to solve these, what we want to do is we can either solve it by factoring, if you remember how to do that, or probably what's easier is solve by graphing. So on your calculator, just graph that equation and find the x-intercepts, or you can use the solver on your calculator. Okay, so on your calculator, let me just open up a new page and I'll explain how to do this. So our equation was x squared plus 3x minus 4. Okay, so on your calculator, hit the math button, then choose solver, which is right at the very bottom of the list, and then you have to type in the equation. So enter x squared plus 3x minus 4 equal to 0, and I think they give you the 0 part first, so you'd write it as 0 equals. Okay, so you plug in that equation, and then right below it has x equals. So what you want to do is you want to guess at a number. So usually what I do is I guess at a 5, and then I put in negative 5. So you do 2 different choices. So you do the first one, put in x equals 5, and then you hit alpha solve. So you got to hit the alpha button, which is the green one, and then hit solve, which is where the enter button is. So go alpha enter, and once you put in the 5, it'll then change that answer to whatever the closest one is to 5. Okay, so in this case, our answer is 4. Right, so if you go alpha solve, put a guess of 5, it's going to give you 4. Then try negative 5, so put in alpha solve negative 5, and it's going to give you the closest one as your answer, and it'll give you an answer of -1. So we'll get the two answers for this equation, 4 and -1, and so it's a pretty fast, easy way to solve these. So let's go back to the last page. So we got x equals 4 and x equals -1 as our two solutions. So what we just got to be careful of is, are these both valid answers? So if we go back to our original question, if you see right at the top here, our non-permissibles were +1, and then for our second one, if we go to the factored step, we'd have +1 and -1 as well. So x can't be 1 or -1, so if we go back to look at our answers, you see that we had -1 as one of our choices, so that means the -1 answer is no good. So we would just get x equals 4 as our only solution for this question. And that's it. We'll stop there.